So I was inspired by the BSV developer website, and they're talking about tokenization, and they're showing us a little pseudocode here. And they go into how this is actually what a contract might look like for tokenizing coupons. A coupon system with blockchain tokenization uses distributed ledger technology, so that is a blockchain, and it represents coupons as digital tokens. And so each coupon is tokenized as a UTXO. And I won't get too much into what a UTXO is, but think of it as an envelope with one or more Satoshis. And if you didn't know, there are 100 million Satoshis in one BSV token. So when I teach about Bitcoin as Satoshi's original vision. So that is called BSV, Bitcoin SV. Anyway, this tokenization process combines the security of blockchain with the flexibility of digital coupons, and it revolutionizes, or rather it can revolutionize, how businesses approach customer incentives and loyalty programs. I'm just going to walk you through sort of a pseudo minting. So we click the button to mint a batch, and it's really as easy as that once you have the code written. So we're going to mint a coupon batch, and we have 1,000 coupons at $5 each, and we get a TX ID. That means a transaction ID, and that is represented on the blockchain. So does each coupon mean that we have $5 worth of Bitcoin? No, it does not. That is metadata, and I'll get into that in a second. So let me just show you this pseudocode again, and we won't go too much into it, but basically it is just gathering transactions or UTXOs that you own, and it is preparing them to be spent into a new UTXO that will be these 1,000 coupons, and it's kind of that simple. Each of these coupons will be represented by one Satoshi, so that's not very much. It's a tiny, tiny, tiny amount. So our next step, we're going to talk about this overlay network integration. So an overlay network in the BSV blockchain, and this is very new. The architects are hard at work creating this potential for massive scalability. But just think of an overlay network. I mean, it's basically software, but it's integrated directly into the base layer of the blockchain. So it has a lot of integrity. But in this case, this specific overlay network would be with respect to these coupons. And so this overlay network would efficiently store and manage detailed coupon metadata. So that would be your amount, your discount amount. It would be what stores you can spend it in. Perhaps it would be geography. Maybe there's an expiration date. So there's all kinds of things that could be stored as this metadata on the overlay network. The overlay networks enable fast querying and retrieval of coupon information. It supports real-time tracking of coupon statuses, and it facilitates advanced analytics and reporting. So I'm just going to show this is again pseudocode, but the idea is that you are directly connected to that TX ID of the original mint. These overlay networks are, or in this case, this overlay network is. So bingo, we have 1,000 coupons created in one batch linked to overlay data. So it ensures the uniqueness and ownership of each coupon. It allows for efficient creation of many coupons in a single transaction. The overlay network provides fast access to detailed metadata for each coupon. You can see here that the blockchain and the overlay network are locked together. That's the integrity. So the merchant creates digital coupons on the blockchain, each represented by a unique UTXO. Coupons are distributed to customers through various channels, emails, app, etc. The customer receives the digital coupon in their wallet ready for use. And redemption and reclamation, this is interesting. So the customer uses the coupon at the merchant, triggering a blockchain transaction to validate and redeem it. And so there's a cost-saving feature in this. So if you think about it, when the customer spends the coupon, as we mentioned, the $5 is not what you're spending. That is the discount that you will receive. And the metadata stored on the overlay network tells you what that discount would be. I mean, this is all invisible to the consumer, but this is what is behind it. So, but that one Satoshi, when the customer redeems the coupon, that gets sent back to the merchant, or at least it could. There's a lot of ways that this could be done. So at scale, this process saves significant transaction fees and minimizes the need for additional funding. So let's just look at one cost-saving example. So printing costs for 1 million paper coupons, let's say it's 10,000 bucks. Distribution costs, let's say it's 50,000. Processing and validation costs 5,000. So we got 65K in cost. So in a blockchain-based system, cost for 1 million Satoshis today, sub 1 penny. Transaction fees for minting, let's say it's 50 cents. I don't know. It's, you know, it's very, very minimal. So we'll have to see how all this shakes out. But the idea is that transaction fees will be very minimal. So the overlay network cost, let's say it's $1,000 a year. I don't know what those subscription fees will be. It depends on the business owner for this basically new business model. So our total cost is 1,000. So look at the difference between these two costs. Now, obviously, this is, let's call it pseudo market research, but you get the idea. There's a lot of room for cost savings. This is from the overlay network. So this is the power of that. So you can see all your active coupons, and this is just from a subscription to this overlay network. Your total customer cost savings would be on the dashboard, unique customers, redemption rate. Anyway, cool, fun stuff. And let's see, did I cover everything? Yeah, you can see all this fancy stuff that you can get. Anyway, I had fun creating this, and I hope that you learned something about the power of tokenization on the BSV blockchain, and I hope it gets you thinking about the many things that you can do. Thanks for watching.